Hey everyone, this is the SIGOP KMS meeting number 6 for February 8th, 2022. Get started. I think we had some action items from last time to sort of think about some of this stuff. And I know, Christoph, you had made some suggestions in the Slack channel. You want to talk about what they've discussed or thought of so far?
Yeah, so basically, usually before one starts to reinvent the wheel, it's always good to check which wheels are out there. So I kind of Googled and, well, I'm not using Google, actually, I'm using a different search engine, but I queried the internet and found out that, that there is a Google library that is called Think. And I remember that in my previous company, someone referred to this kind of well-defined library that more or less tries to protect the users from shooting themselves in the feet. And I was curious to look at it, if there may be some nice nuggets that could be useful for us. And then I ran into the topic of KMS, that they support KMS as a first class citizen. So this drew my attention. I looked into it. And from what I could see is that you can give them an IO writer and reader and really define where you want to store the things, and they store it as proto buff, I think, if I remember it correctly. Yeah, and I think when we would go for a solution, either we would have this kind of this custom solution where we kind of think around with the binary, or we just serialize a struct, right? So at some point it would make sense. So I just had a high-level view on the library, went through the source code a little bit, and it looked super useful. So what I also like, and I thought it would be useful also for the reference implementation, is that like for Kubernetes, the smallest unit is not the container but the pod. So for them, it's not the key itself, but it's more like the key set. And they when you create a new key set with a new key, it has all this management built into it that you can rotate the keys and stuff like that. So it had some super sound looking design decisions, and this is yeah, I thought I proposed it, and maybe someone thinks it's useful.
So when you say it integrates with KMSs, what does that exactly look like? What does that mean?
So from the documents, what I could see is that maybe you could open it up. But what I could see is that they want a URI, and
Nish, we can see your Slack. Oh, sorry, I thought I don't want to see your private messages.
I'm just opening the.
Yeah, so there are Go examples. Let me search for it. Yes, so let me share the URL in the chat. So I just click on the very first Go link, and it leads to a how-to with Go. Or you go in the current status. There's the reference to languages. Okay. Yeah, and when you scroll down, you see that further down. Yeah, there's a QRI and a credentials path, and then you have a client for your KMS.
Interesting. Okay, so it has a direct integration with GCP's KMS. Does it also support like AKS and other things?
I hope so.
I think it says
on
AWS KMS, Google KMS, HashiCorp are supported out of the box.
And not EKS?
Not EKS, not Azure.
Oh yeah, I thought. Oh, sorry. I'm okay.
No, AWS KMS should
Yeah, I misheard. I thought she said AKS. No. Okay, so
No.
Amazon and Google are supported in HashiCorp server, but not Microsoft and not just not.
Well, I guess it should be possible to contribute to them, so they support also Amazon, right? Sorry, Microsoft.
Yeah, I mean, if we use this library, right, and it ends up in our reference implementation, I want it to be fair, right? I don't want to just have a bunch of like easy use knobs for everybody but AKS. Basically, like that doesn't seem right. But I do think, if I remember correctly, doesn't HashiCorp support like a pass-through like mode where it uses different vaults under the hood?
Yeah, I mean, there is an adapter where you can connect it to different KMS backends. Like I think it has for GCP and Azure Keyword for that. But in terms of auth and all that, I think it doesn't support like all the auth scenarios. Like it supports very basic auth, which is like client ID password kind of thing.
Oh, I see, and that might not be sufficient. That might
not with identities and all that.
Yeah, okay, that would be kind of crappy. We don't want to promote that. That would be bad. Okay.
There's an issue for the Azure one, and it doesn't look like it's there, and people are asking for it.
Okay. So, I mean, this would be in a sense, I had not imagined our reference implementation supporting any of the cloud providers. I had only imagined it supporting like PKCS 11 or something of that vein, right? Because that's just a standard and it's just talking to hardware.
I mean, we don't have to support anything in the reference implementation. Like we just have to come up with like the interfaces and the tool that they can reuse. And then we could have like kind of a test version of this reference library that would only support like PC key. I don't remember like the name of it, but yeah, it will only support like the bare minimum, and that we would use then for the test.
Yeah, that's fair. I guess we don't have to use any of their. So let's see. So you get some kind of a client. Register it in some global place, which is so sketch. I hate global registries. You get some key. I guess that's probably a handle or something to a key. Yeah. But no, this does sound interesting. And I don't have strong opinions one way or the other. I do think we should try to reuse code where we can. We invent this. I think Christoph, you had said that the key set stuff helps with like rotation. I think that was
Yeah, exactly. So this was the thing that really attracts me to the concept that hey, key set is the minimal thing we're working with. And this is what you see. The very first thing that they do is they create a key set, and to handle this key set, they create a handle for it, and then they use this weird templates to specify kind of a combination of algorithm to cryptographic primitives. Yeah, exactly. And this was usually, so before that I looked into it without the KMS feature, so I don't think that is super tightly coupled to it. I think at the end of the day it doesn't care all too much about where the master key comes from. And I guess with additional layer of the local CAC, maybe we would need to tinker around this library and add something on top or something. I don't know how extendable it is, so I just had a brief look into it. But if there would be some,
oh, sorry, I was gonna ask, is master key literally like a slice of bytes, or is it like an interface that can be directly implemented by like a cloud KMS, right? The reason I ask is we want to limit how many in memory like keys we're holding, right, to the bare minimum, and we want to make sure that at some point, at some level, like whatever key we're using for our encryption is encrypted with the upstream cloud KMS or whatever, or whatever you have. I guess we don't need necessarily the key hierarchy for a hardware KMS, but we probably do need it for the cloud KMS.
Yeah, I would need to look at it, but we see the usage below that we have the initial key handle that we created, and we want to encrypt the mem key set, so the key set that lives in the memory, and we want to encrypt it with the master key that we got from the KMS. So I would just check what type it is, right? The master key, but I would assume it needs to be some same representation of it.
Okay. Cool. I think I saw some comments on that doc, our doc. Did you want to talk about them? I think maybe Damien, you had written something.
Yeah, I just kind of drafted some ideas on like the topic of what would that imply to introduce like the hierarchy of the key in the KMS provider. And it's just like some ideas about like what problem we might encounter and what thing we might want to change, especially like in terms of storage. Last time we discussed like that we might need to rethink how the data is stored and try to bring a new format. So yeah, in like the different ideas I had were mostly focused around like making it so that the APIs, it's like the change is seamless to the API server, like whether there is key hierarchy in place or not. Like the API server shouldn't be aware of that because like it's really up to the provider to enable it and then use it, because like from the API server side, nothing will really change. Like it will only encrypt its DKs and decrypt them. And besides that, well, all the thing that is under the hood regarding the like the local KK that we discussed before is really up to the provider. So I was trying to figure out like how can we make it seamless to the API server so that it works even if we don't have a local KK. And yeah, so far like my ideas were to change a bit the store, to include like every time like we store a data, include like an ID for the local KK, whether it exists or not. And then this ID will be given back by the provider. Like if in the encryption response, we say that the provider will provide the UID of the local KK in case it was used. Then we can use it to store both like the data and associate the DK with the local KK it was encrypted with. And then in the decryption request, we can just put the UID in there so that like when the API server sends a request to the KMS provider, it can tell it like which key need to be used to decrypt this particular data. So it was more like trying to keep track of the local KK that was used to encrypt the DK.
Yeah, so I imagine something like this would happen. By the way, I don't know if y'all have really thought about some of this on, if you look at the from line where you have 2 bytes deck written, right? That encodes the length of the deck. So if your deck doesn't fit in 2 bytes, like the length of it, just garbage will get written.
Yeah.
And then like horrible things will happen when you try to decode data back. So like I love how like there's this implicit contract with the KMS plugin. Do not ever return me data that has a length of greater than 2 bytes, because otherwise I won't be able to encode it correctly. Like, it's not written anywhere. That's literally just like a random implementation detail.
Yeah, it's really like in the code you have like 2 lines of code that tells you that the DK must not be like more than 2 bytes.
Yeah, but we don't enforce it in the code. It'll just like horrendously write nonsense.
I think we do, because we kind of do, because like we are getting the 2 bytes to
yeah, you're right. We assume it's just 2 bytes,
yeah,
and we're gonna blindly take that. So like we'll just take the upper 2 bytes.
If it errors, well, it wasn't stored well. Yeah.
Yeah, it's crap. So one thing, just from all of this, right, is if once we get down to like we're gonna start adding new stuff to storage, I want to get away from this horrible prefix spaghetti we got going on. Like I'd take just a simple JSON structure over this. Like at least a JSON structure you could read with like tool or something like this thing. So, but that aside, like I think the hardest part of this is since we have to like remain backwards compatible, we would have to allow the API server to send us empty, like, you know, key ID, and
Oh yeah, that's something I didn't mention. So my idea was that if the API server sends an empty key ID, then it will tell like the provider that it needs to, and like it doesn't need to take a particular key to, or no, that wouldn't, no, that's not the case. That will tell the provider that it needs to reach out to the KMS in the cloud rather than just looking at the local keys.
I think now for backward compatibility, yes, like it would just reach the external KMS, but even in the future, for some reason, if there is no key ID in the decrypt request, then maybe the KMS plugin can just try to decrypt with the existing keys in the key set.
Yeah, I think that we could handle. Like I don't think that's a big deal. I think what it comes, I mean, so certainly the larger question is, what is the storage format going to look like? What are we going? Are we going with a binary format for compactness? Are we going with a more friendly format? Not sure. One thing I would like that to come out of this is it should be reasonable to write a tool that can look at the data inside of etcd and do something with it.
Yeah.
Right. Like,
could we maybe even extend the etcd? No, because we couldn't extend etcd ctl to handle that particular case.
No, but but we should be able to like get data out of etcd and not necessarily require the API server to do like stuff, right? Like if it's in a nice structured format with keys and values, right, you could use regular tools, right? Whereas in this case, you have to like very carefully like strip off a prefix and very carefully interpret, like I think it's big endian. I don't remember how the length is encoded, but right, like, and it's a certain amount of bytes. Like it becomes very impractical very quick, right? Like you have to effectively write a Go program or something equivalent to parse it out.
But I wonder the cost of like moving away from the binary format, because like since we have to prepend this information to all the kind of secrets or all the resources that are encrypted, I can see it becoming quite.
Yeah, so I think what we could do is if we went with like Proto, like Protobuf, we could do what Kubernetes does, right? So Kubernetes, for all Proto requests, it has the bytes K8S, and then it's got like a 2-byte version number, which I think is either 01 or 00 today. And it's never been changed, and that's it. That's the raw prefix of all that data, and the rest is just Proto data. What my thought would be is we could do something like that, a very small prefix to help our it had to be different so that it couldn't be confused with existing Proto data that's unencrypted, stored, right? But it could be something of that vein. But then the rest of the data is in the actual Proto, right? So the way we handle that in the rest of the decoding layer is there's guaranteed to be a type meta at the top level, which gets decoded into a runtime.unknown, which then gives you enough information to find the actual resulting type. We don't have to get into that, but the point is though that we have a ton of machinery today to take binary data off the wire that's not self-describing, our APIs, and then figure out where to go, get the right Go struct and decode into it. So there's no reason we can't leverage that same thing here. It's just
yeah. Thinking about it, like, should we make the change for all the encryption type? Because like as far as you like from the example that you showed, like since we have like this meta type in the Proto, then we can infer like which encryption type was used, either it's, whether it's KMS, whether it's AES-CBC. And then like if we kind of rework this whole like storage layer, I think we could then separate like the different type of encryption and have its own like for KMS.
Yeah, I mean, I'm not too strongly opinionated on that. I'm already skeptical of the value that most of this stuff provides, and then when you combine it with like, I'm gonna do a local file on your disk, I'm extra skeptical of the value that is now being provided. So like, I don't know, I don't really particularly feel compelled to like improve that. If we want to just to be consistent, I could buy that, just so that we move away from this prefix spaghetti to there's a very small strict prefix that is just for for saying that this is encrypted data basically, and then you have this nice structured.
Yeah, I guess it's also more like in terms of consistency, like if you want to build a tool to then get this data out of etcd, as you mentioned, it's easier like if we are consistent between all the encryption types rather than like have a dedicated format for KMS and then the whole different like binary like format for the other encryption types. So I would rather like have something consistent rather than just making the change for KMS because we need to improve KMS.
Yeah, that's fair.
Hey, sorry, obviously I missed the past few meetings, so but I also didn't see this quite clearly stated in the doc yet. There's a lot of talks about the data being stored. How is the keg actually being stored? Like, is it the actual? It's mentioned UUID, right? So when there's a decrypt request, does that mean the API server would need to go look for the local keg first? Where is that?
Oh, okay. So the idea that is sort of being proposed here is in the encryption response. So when we hand a data encryption key to the KMS plugin, we're saying in the encryption response, it will hand us an optional UID of whatever key thing it used, like just a reference, right? And when we store that data, however we store it, we're going to hold on to that UID. And then on the other end, when we ask the system, the KMS plugin, hey, I want this decrypted, if we happen to know a UID, if we were originally passed one, we'll also pass it back as effectively as a hint. So that way the KMS plugin, if it already has that locally, like, it has the capability of somehow locally handling that key, it does so. If it doesn't, it figures out what it needs to do. But no matter what, like a KMS plugin is always going to be free to ignore it and just say, I only have this one key configured. I don't know any other keys, or I'm just going to use this one. Or
sure,
I have
but where is the local keg stored?
So from the API server's perspective, it doesn't store it, right? Because it never sees the keg, it only sees an ID. But it would, if in this world, we are saying that we would make a change to the storage format of encrypted data on disk to have a new field to optionally store a UID that refers to the UID of whatever key encryption key is being used by the KMS plugin. And this is all in service of the idea that we want to be able to send a decrypt request to the KMS plugin, and from that be able to. Sorry, let me rephrase that. So today, if you want to do rotation and you're using KMS, you have to configure more than one KMS at a time to the API server. So that way it can detect if it was the first one or the second one that was used, and if it's the second one, it's like, oh, it's out of date, right? Basically, we need to basically make that information available through the KMS API itself, right? So we basically need a semantic to be able to stay, have I, as I've been using the KMS API, basically what's the current key ID that I'm seeing? And if that's not the same as the key ID I'm using to decrypt this, I know it's old. So it's a little convoluted, and there's still a bit of a slight offset in there.
I mean, the UID is a lookup, right? But the actual local CAC is in memory, is it?
That is up to the KMS plugin to decide, right? It could be directly just using or like a cloud KMS and directly doing encryption and decryption.
Okay.
And then the ID is, I don't know, like maybe the name in cloud KMS or whatever, or the UUID, like whatever unique identifier that key has in the system. Or it could have generated a local key encryption key, had that in memory, go ahead and store it in a so in that mode, what it would have to do is encrypt it using the cloud KMS,
yeah,
and then return it in the UID to the and return the encrypted thing.
Right. So in some cases, you are doing like two decryptions.
Yes.
You're using cloud.
Yeah, basically that's where the hierarchy comes in, right? Like the idea is that the only reason we are really worried about these decryptions is in a lot of situations you're using a cloud KMS, which means you're using basically network calls to get all this data.
Right.
If you were using PKCS11, this does not matter. A local KMS can trivially handle thousands of decryptions, right? Because it's in hardware. There's no network IO. So what we're saying is, well, the idea here is to say that is an implementation detail of plugins, but it's an important one. So instead of the API server somehow trying to bend over backwards and support it, why don't we just support it in our reference implementation via a key hierarchy? So that way you can choose to run that if you want to. You don't have to, right? So if you have a local hardware KMS, you don't need this key hierarchy, so just don't use it. But in the case we're using a cloud KMS, your plugin will generate a local key encryption key, have the cloud KMS encrypted for it, and so it can store it.
For the lifetime that you've configured. And then once that expires, next time you call the decrypt, it will call the cloud KMS to decrypt again. So it's possible that worst case scenario, you are calling the cloud KMS to decrypt and then the local CAG to decrypt again. So two decryptions.
Yes, in the worst case, when you first start up, you're going to do probably multiple double decryptions.
Right,
But the idea is once you start up, you should have used the local key encryption key for most of the encryption, right?
Right,
and
after the first time. Yeah.
Yes.
Yeah.
Right. And so what that to me, what needs to also be included with like a reference of this local key encryption key, if that reference is included, I think you also have to include some kind of TTL back to the API server to tell it, hey, for this duration, or maybe until this time, or something like that, you can assume that this is going to be my key.
Right.
And that I think
do we need to do that? Can we just like let the KMS plugin handle all the life cycle?
I don't think it can, because the API server needs to know when it already has a key that's cached. Right? When it has a key that's cached in its memory, it needs to know if that was cached and was from an old key or a new key, right? So it has to have a concept of how long did an old key last? So that way it can invalidate its cache and say, I realize that I happen to have this, but I need to like ask the KMS anyway to redo the encryption because it told me that that key encryption key was only good for 1 hour and I've held on to it for more than an hour. Like or I've held on to a result of its use for more than an hour.
So with this proposal, when we talk about key rotation, are we talking about the local CAC or the cloud CAC?
So
or
From the
both?
perspective of the API server, it doesn't know
Mhm.
and it doesn't want to. So the cloud rotation is, I guess, kind of out of scope in the sense that we can't automate it for you. Like we can do the local stuff and keep that just sort of happening all the time. It's like we within our process.
Mhm.
But yeah, you would need some level of custom extension, right, with the reference implementation in your Cloud KMS to do that, and then you would be able to funnel that information through the stack just as a way of saying, well, everything is new now, so everything has to rotate.
Right.
Yeah.
So basically with this new approach, you get auto rotation for free. Like auto rotation of the local CAC for free.
Yeah.
Right.
And it's I don't know if it would need to be configurable or not, or if it's just kind of fine, because no matter what, when you have multiple instances of API server, they're going to see different data and different keys, right? So the idea would be is like, if one process generated a local key in memory, the other ones won't know about it. But when they are asked to decode data that needs that key, they'll basically have to go through the whole process of basically building up their cache. And the final cache breaker is the Cloud KMS, right? Like no matter what, you can use the Cloud KMS plus the encrypted data to get back the master key that you needed for that particular instance, right?
But I think cloud CAC rotation is also a requirement still, right?
Yeah, I mean, so I would say that we want to make it as easy as possible.
But would this new proposal actually make it harder? Because now whenever you're introducing a new cloud CAC, now you have to support both the old local CAC and the new local CAC for a while, right?
You have to do that no matter what.
That's true.
That's like literally inherent to the rotation problem. You just can't just jump to the new one.
Yeah.
Yeah, I mean, today we do it anyways. Like we decrypt all the existing secrets with the new one and re-encrypt it.
Right.
Yeah, so I think what this would enable is a more graceful and sort of lazy approach where you could imagine where that your Cloud KMS integration, like every single day creates a new version of the key, of its global key, and starts encrypting with that, but it keeps the old ones around. And if the system is auto rotating under the hood, it would slowly pick up the new key, right? As it's being used, right? It would notice that things have shifted. And if you really wanted to force it, you could do a full storage migration to the Kubernetes API if you wanted, but it would sort of lazily just be moving forward. Right, and it's just basically, you need to force a storage migration when you are insisting on deleting an old version of the cloud key. When you're saying, I need to get rid of this old revision, then you have to force a storage migration to basically propagate it up to the latest key. Right? And so like we do need to have a guarantee that somehow, some way we can force through storage migration the latest cloud key to be used. As long as we can cause that guarantee to be asserted, you do a storage migration and you can nuke all the old versions. And that's basically a rotation, right? Like the rotation system is always happening and you want to force it, cool. Do a storage migration, which is just a bunch of writes to etcd through the Kubernetes API. Once that is successful, nuke all the old versions and you're good, right? And the nice thing is there's no like restarting API servers, there's none of this, right? Because you basically encoded that logic within the API enough to do it.
Right.
I'm not saying any of this is easy, by the way. This is like
yeah.
pain in the butt to write.
Well,
I'm wondering
sorry, go ahead.
I'm wondering if I would like to delete any CAC, no matter how old it is, doesn't take that much space up. I think that the only problem would be that the older a key gets, the more failed iterations it would have in between, right? If there's no UID, but with a UID, it should be kind of straightforward.
Yeah, I think it maybe just a matter of cost, Like I'm sure like having many revisions in the cloud KMS might increase your cloud bill by some amount. I don't know how much they cost. I don't think they necessarily cost that much.
I mean, a huge key is 32 bytes, right? Just imagine we rotate it once a day, then we would have like what, maybe a couple of megabytes per year.
Yeah, but the cloud KMS stuff isn't built by like sane metrics of how many bytes there are. It's like built by like
Okay.
arbitrary details of this is the value this provides you.
Yeah, sure. Now it makes sense. Yeah.
Yeah, that's what I mean,
But-
right? Like a while back, like the GKE folks were trying to change a bunch of stuff about how health checks are done today, because they're like, oh, these health checks are costing customers a bunch of money and they're not happy about that. I was like, well, just don't charge them for it. Like, why are you like why are you bugging me about like the fact that you're overcharging your customers? I don't care. Like, it's not my fault. But that as an aside, we just need like a dedicated health check API on KMS, so that way a plugin can implement whatever it thinks is like a valid way of doing a health check. And perhaps some of this stuff feeds into it. So you could imagine our health check API could include like the current level, the current UID the API server thinks is latest. And so that way when it health checks with the KMS, like the KMS could be like, oh, I need to make sure I have that key locally. And if it like can't, it could return like, I don't know, some kind of response, who knows. I don't know, I haven't thought through that through, but I do think we need a dedicated health check API so that way we don't have to ask people to like futz around it basically. Because I think what they ended up doing is inside of their KMS plugin, they just literally like look for the string held as the key that's being asked to be encrypted and just return okay. It's just like, well, okay, that's fine, I guess.
Yeah, the health proposal is also part of this. Like, I think somewhere down we proposed that like having a separate health API. And I think, yeah, some of the providers basically cache the health check response. So if you do a health check within 5 minutes, they just send okay if the last one was okay. And then the new health check is only done after the interval.
So one thing that reminds me is the KEP we just merged for the observability stuff changes the existing beta API and adds a new field optionally behind a feature flag, blah. Like, we did all the right things, but it's changing the existing thing. For me, I kind of feel like this stuff we would put behind a feature flag and a full API version. So like V1 beta 2 of the gRPC API. And then in there, we can really starting to look at all of our choices, because if we had to put a feature flag that started at alpha for like observability, I can already guarantee you that we're going to be asked for this. If that's the case, we don't need to immediately start off with, oh, backwards compatibility and all this and all that. Like we're basically being told it doesn't have to be backwards compatible because you're starting a brand new feature, basically, right?
But you want to be backward compatible.
No, like what I'm saying is, if you have to have a minimum 3 version rollout anyway, you're not gaining anything from the backwards compatibility because you're saying that it has to be staged as if it was not backwards compatible to begin with, right? And if we need to make all of these crazy storage version changes anyway, then it's like just do it. Like. I just feel like it would be just easier to just do it like that instead of trying to be like, well, is this variation backwards compatible with this variation?
That's a good point, though. I think it will impact migration a lot, though. Like, yeah.
Yeah. So I think what we would end up having to do, which I really hate.
I mean, just imagine like I'm upgrading my cluster. And now I'm like, oh crap, I need to make sure the plugin is upgraded like at the same time.
So I think the way we would do this is within the encryption configuration where you configure the KMS plugin or something like that.
Yeah.
we would basically leave the existing V1 beta 1 alone, and that would continue in its own format, in its own capability indefinitely, basically. And when we introduce this new thing, right, maybe a completely brand new configuration in that struct, you can then specify ahead, right? You can specify the same KMS plugin, but running in a completely different mode as your new write key, right, basically. And so you can migrate, right? And the idea would be is that we would leave the old functionality for many, many, many releases, right? To allow you to say, okay, yeah, I'm ready for the new thing, et cetera. And it might be that we basically maybe we freeze the beta API and just leave it alone and just say, all right, here's the new one. We're gonna go through all of its revisions, right? And that's the one that we want you to use. Where we don't really particularly want to force you into a place that you don't want to be. So just leave the whole thing alone.
Don't use them at the same time.
No, you can use them at the same time, right? The idea would be is that you have more than one provider configured, right? And if you had the old KMS plugin sitting around, you could leave it, configure the new KMS plugin as a new provider, and gently migrate to it as you want to, right? So you can basically use both at the same time and migrate away, right? Basically, you would have 2 Unix domain sockets running on your.
Yeah, that's. But why? Like, you don't want them to do that.
It would be so that you were not forced to migrate away from the old one, right? If you did not immediately feel the need,
Sure.
right? If you wanted to have, right? Because you still need the ability to downgrade, right? So you might want both of them around, able to swap them around and do whatever you want.
But they could definitely, I mean, the encryption decryption could happen at the same time. You might end up having really strange behaviors, right?
Well, I mean, only one provider is used for a given encryption or decryption operation, right?
Right. The first one, it's in the configuration, will be used for encrypt. But for decrypt, I think everything is tried until one of them succeeds.
Yeah.
Yeah. So whichever you put first is your write key, and all of the others are your read keys. And so the idea is that whenever you're comfortable using the new stuff as your write key, you put it at the top of the list and you run a storage migration. But then, if you decide you need to downgrade to an old version, you put the old KMS plugin as your write key, do another storage migration. Now you're back to the old format, and then you can downgrade your cluster to the old version, and you can still use the old stuff. But no matter what, though, we're talking about many releases of overlap of both of these functionalities. So like downgrade and upgrade becomes much easier because there'll be probably at least 3 versions of the API server that know about both of them.
Right. Right.
So I think we're relatively well covered there, as long as we express it basically as a new configuration in the encryption configuration structure.
Sorry, there was a point you made earlier. I said, would the local key be in memory? And you said that's up to the plugins implementation. Wouldn't that be a bad thing? Like, we probably don't want it to be in memory, right? So that data isn't lost. Right.
So we do need it to be in memory because in the cloud scenario, we want to be able to decrypt like 100,000 secrets on startup with like 10 cloud calls, not 10,000 or 100,000 cloud calls, right? So we do need, basically we need the key hierarchy to break that problem, right? We say that, like, at the end of the day, we are already okay with a Go process holding data encryption keys in memory and using them on our behalf in a sort of an undefined AES CBC model that is unconfigurable.
Let me clarify. Like, I mean, it's in memory to help performance, but like it has to be in storage at some point, right? Because that data has to exist for decryption.
Yeah, so I would assume we store it maybe in etcd or somewhere on the cloud provider side. And then, for example, when we start, imagine we put in the etcd, that we load it out of etcd, and we see, okay, we need this keg from the cloud provider, then we
Right.
get it in the plugin, we decrypt it, and then the plugin just had one decryption call to the cloud provider, and can now has now the local CAC and can decrypt all the DEX.
Right, but the local CAC is in SCD as well.
Right. Yeah.
There
So
needs to
those,
be some.
Start somewhere.
Yeah,
Go ahead.
there needs to be some kind of contract, right? Like it needs to be there in HCD, because if the KMS plugin restarts and then it basically loses everything.
That's why I'm saying it can't just be in memory.
Right.
right. Right. So the way I imagine this working is your process starts up, the plugin starts up. It does one cloud KMS call where it says, hey, I generated these 32 bytes. Encrypt them for me and hand me the encrypted result. Okay. Right. And then once the encrypted result is handed to it, every single time it does an encryption and decryption with the API server, as the ID of the key, it hands it the encrypted blob as the ID of the key.
That makes
right?
sense.
So when it gets it back, it's like, cool. I'm gonna ask my cloud KMS to decrypt this ID because that's literally the key.
And once it's decrypted, it's in memory, and then I'll use it for the lifetime of that. Okay, cool.
Yeah,
now
it's literally the same exact model.
Yeah, I know. But I just didn't see it in the doc, and I know it's too early. But that was like the part that I was stuck on. Sorry.
Yeah. So for me, it was just basically reusing the data encryption concept with one extra layer.
Yeah, that makes perfect sense now. Okay. Okay. All right.
Yeah. So yeah, it is all stored, but like sort of in a weird, funky way.
And I guess like what it will look like is still TBD, right? So.
Yeah, no, we're still talking high level.
Okay.
Right?
Okay.
Though I don't know about you guys, but like for me, a lot of this stuff becomes a lot more clear if I go try to like make a thing. Like if I actually go try to like build something, no matter how hacky.
For sure.
So we might be at the stage to actually like try to probe at a reference implementation somewhere.
Awesome.
I have a question. So currently we have different KMS plugins, and they're provided by the cloud providers, right? So we have one for Google, one for Amazon, one for Microsoft. So basically, when we create a reference implementation, it's kind of the user of the Kubernetes cluster would need to decide, okay, do I want to continue with one KMS plugin or move to the other KMS plugin? So when we would have a KMS plugin reference implementation, we would need to support all the possible cloud providers, or would we kind of delegate it to the KMS plugins of the cloud providers, or how would we go forward?
So I think that is mostly a policy question for SIGAuth itself, right? So like, as we have this, we have the secrets CSI store driver, right? That does support a bunch of extensions to a bunch of different places, right? We could follow a similar model where we allow, like where we have a canonical repo where we allow extensions and support. We could do that. Or we could have a minimal reference implementation that purposely only supports like PKCS 11, because that's agnostic to any cloud provider and it isn't harmful to anyone for it to exist, and then ask the cloud providers to maintain their own implementations. I don't really have a strong opinion one way or the other. I think either way, I think if we get to a state where the foundation of all this stuff is the reference implementation, I think we've been successful. The only concern I ever have with something like CSI secret store driver, where we have a bunch of extension points, is we don't want to play kingmaker. Right, like we don't want to be a gatekeeper where we say that you can't have part in this reference implementation. We don't want to be in that state.
Yeah, if I can give an example from SIG instrumentation, what we did, like we have a reference implementation for like all the metrics API, and what we do is that this is a Kubernetes SIG project, and like there are a few projects that are reusing it, and we kind of endorse them. So they are now part of also Kubernetes SIG. And it's like, if we want to guide users to any project that we know support the reference implementation, we just guide them to this project. So what we could do is kind of the same, is that like we leave the reference implementation as its own, and then every little cloud provider implementation that reuse this reference implementation, the SIG could also endorse them and just bring more visibility to it by adding it to the Kubernetes SIG's organization. But that's up to Sigurd to decide at the end. It's really more of the scope.
So Rita and Nish, you guys have been running the secret CSI sort driver for a while. What do you feel has been successful or unsuccessful in this kind of model?
So, I mean, right before the move, we extracted the providers out of the code base and made it out of tree, right? And then like today, the driver resides in Kubernetes 6. And then anytime we make changes, we ensure like backward compatibility and all that. And then as part of the community call, we have different providers that come in who use the driver, right? So we do define a criteria for what is a supported driver, like in terms of the basic tests that they need to have and all those, like we just regulate that. And when we say supported provider, we say adding them in our documentation, but anyone can implement a provider that works and like they can still go and say like users can use this and all those, right? And then each provider resides in their own GitHub org, like the Azure one resides in Azure org and then the GCP one is in GCP. So that model has worked well. Like in terms of adding new items to the driver, like it's mostly a community-driven decision, like where all the providers think some feature is worth it, then we decide if it's something that needs to be added at the provider level or it's something that we can move at the driver. And then if it's something at the driver, like we always try to have it at the driver level so that it can just work out of the box for different providers. But I think, yeah, like that's how we've been doing it right now. And then we already have 4 supported providers today. And then we also have a lot of different other implementations that work.
Yes, I mean, I guess I mean, it seems like you guys are having success, right? So we could probably mirror the same process, right? I guess I'm less sure if this extension point needs that level of like support in a sense. So like I can see there's a ton of different secret stores and like all sorts of people wanting to interface with Kubernetes because it's application centric, and that is what the platform is. This is like an infrastructure detail, right? Like in AKS, EKS, and GKE, I never expect to have to configure this. I expect this to just be configured and just running all the time. Or maybe I have to opt into it or whatever because there's some performance penalty, but once I opt in, it should just work. I shouldn't have to configure anything. So maybe it is just that we don't ever expect there to be more than like 7 implementations, like the cloud providers and some of the other big vendors, and that's basically it.
But also in terms of reference implementation, we're saying we provide an example on how to do it. But in addition, it's also like a library that they can just import and then do like key set generation, like at least the basic things like key set and the UID is what we talked about, like logging with UID and all those, right? So I think, yeah, the example implementation from the reference library will be useful for the KMS plugin implementers to see, oh, okay, this is how it works and all of those. And then obviously based on versioning, they can decide which version of the library that they want to use to support this particular feature and so on. But I think it does not require the level of contract that we have for driver providers today. Like, I don't think that's necessary.
That's right. I think the libraries might, right? But not the reference implementation.
Right.
Is it a must that they have to use the library? That's
no,
that's the contract, right? Is go ahead.
I was going to say the contract is a gRPC API, right? You're welcome to implement it all yourself. What we're saying is that's a lot of work, and there's going to be a ton of best practices, and just all these nice to haves. So why do it yourself? I mean, if you insist, that's okay too. But we really want to make it so that, you know, like, I don't know if DigitalOcean, for example, supports KMS and Kubernetes today, but let's say they don't, and, you know, they're a smaller cloud and they want to support this, right? They shouldn't have to like spin up an entire engineering team just to like get that built and maintained and supported, right? They should be able to like, yeah, like this is like it should be the equivalent effort of like running Cert Manager, right? It's like well, like, yes, you can go really wrong with Cert Manager if you configure it wrong and it's like starting to issue certs for everything and you didn't, do proper access control or whatever on it. But you didn't have to do all of Acme by hand, right? It did all the shakes for you. That's kind of what I'm feeling here.
Yeah,
Like,
yeah.
if you want the low level stuff because you need the control, sure, it's there.
But again, if it's a library that people are going to use for production use, then that there has to be some backward compatibility contract
I mean,
if they're using it as a library. Otherwise, how are they going? There's no guarantee.
yeah, so I think I would lean in the same way that we say for all Kubernetes libraries, right? Like they're compatible in the sense that they don't break any REST APIs, but they're not compatible at the Go level, right? So you can have compile issues if you bump from one version to just 0.23.2 to 0.23.3, right? You can get a compile error just from bumping those libraries because none of the function signatures are public API. I'm fine with saying that because that's not the contract I'm trying to build. Like nothing in Kubernetes has that level of contract. It's too hard. It takes too much effort. We are out of time. We do have a meeting. Maybe we should just discuss on the Slack channel, figure out some next steps. I think we're having some good discussion, but I think we do need to maybe try to write some code or some API design or something, kind of help us think through this.
Yeah, I think like one outstanding thing is the data format. Like I think we can also follow up on that. But yeah, I think we might be able to try some kind of a POC with the hierarchy stuff just to show how it works. But yeah, we can follow up on the Slack chat.
Cool. Thanks y'all for coming.
Thank you.
Bye.